Hello students, welcome to our class. This lesson, we will learn the high voltage power supply, abnormal fault diagnosis, and elimination of the relevant knowledge. In a pure electric vehicle, after pressing the brake pedal and turning on the stop switch, the instrument is normally lit, but the ready indicator light cannot be normally lit, and the battery indicator light, the vehicle system fault indicator light, the EPB fault warning light, and the ESC fault warning light are also lit. After diagnosis, it is found that the drive system is faulty, and the high voltage cannot be powered on. As a professional technical maintenance personnel, please solve the problem. The course is divided into 3 categories. 1. Understand the high-pressure system overview. 2. Master the principles of high-voltage power distribution components. 3. Master the working principle of pre-charging. 1. Pure electric vehicle high-voltage system overview. The high-voltage system of pure electric vehicle includes power battery, motor controller, drive motor, electric compressor, PTC heater, and other high-voltage components. In addition, it also includes a DC fast charging system and an AC slow charging system. All high-voltage components are powered by a power battery, which is connected through a high-voltage distribution system. Principle of high-voltage distribution components. 2. Healy EV charging and distribution assembly in 1. The integration degree of high-voltage components varies with different models. Healy EV charging and distribution assembly is a 3-in-1 highly integrated high-voltage system, DC-DC converter, OBC onboard charger, and PDU distribution box, which can supply high-voltage DC from the power battery to the vehicle's high-voltage electrical appliances, and can also accept DC from the onboard charger and other components to charge the power battery. At the same time, there are other auxiliary detection functions, sintering detection, voltage detection, and other functions. 3. Charge distribution assembly. The charging and distribution assembly refers to the combination of the vehicle charging system OBC, DC-DC, and DC charging and distribution. Small size, lightweight, power density greater than 2 kW divided by L, wide battery voltage range, suitable for a variety of battery voltage platforms, and DC charging distribution design can be selective and customizable. 4. Charge and discharge principle. The high-voltage direct current output by the power battery is distributed to the drive motor controller through the charge and distribution assembly, and the inverter is converted into 3-phase, adjustable voltage and variable frequency alternating current to supply power to the drive motor and drive the vehicle forward. When the vehicle is slowing down or coasting, the back electromotive force of the motor is rectified into direct current through the IGBT in the motor controller to charge the power battery through the charge distribution assembly. 5. Distribution of electricity principle. The high-voltage DC power is divided into 2 channels when it reaches the charging and distribution assembly, one of which supplies the DC-DC power converter and outputs 13.8 V low-voltage DC power to the low-voltage power supply system. The other one supplies power to the air conditioner compressor or PTC. Receive the AC power from the AC charging port and charge the power battery through the internal boost and rectification. Receive high-voltage direct current from the DC charging port to charge the power battery. 6. Energy consumption. When the vehicle is running, the power battery outputs high-voltage direct current through the charge distribution assembly. The charge distribution assembly distributes high-voltage power to the motor controller, DC-DC power converter, electric compressor, or PTC. 7. Energy recovery. When the vehicle is slowing down or coasting, the wheel drives the motor to rotate, and the motor is in power generation mode. The back electromotive force of the motor is rectified by the IGBT in the motor controller and then charged to the power battery by the charge distribution assembly. 8. DC charging. The DC 500V electric energy output through the DC charging pile is transmitted to the power battery assembly through the DC charging positive and negative contactors in the charge distribution assembly to charge it. 9. AC charging. The electric energy output through the AC charging pile is charged to the vehicle charger in the distribution assembly, and the vehicle charger transfers the AC boost and rectification to the power battery through the DC bus to charge it. Working principle of pre-charging. 1. Working principle of pre-charging. When starting the vehicle or charging the vehicle, in order to alleviate the impact on the high-voltage system, the battery manager first absorbs the positive electrode and the pre-charged contactor, and the high-voltage voltage of the battery pack is loaded onto the high-voltage bus of the motor controller after passing the current limiting resistance of the pre-charged contactor in series. When the motor controller detects that the voltage on the bus is less than 90% of the battery pack voltage, the motor controller feeds a pre-charged signal to the battery manager through the power con channel. After receiving the pre-charged signal, the battery manager controls the negative contactor to pull in and disconnect the pre-charged contactor. 2. Power on at high voltage. Step 1. Wake up and self-check. Set the start switch to on to wake up the BMS. The VCU is started. The high-voltage system outside the battery pack is initialized. The high-voltage line insulation is self-tested, and the test results are sent to the controllers such as BMS through the CON network system. BMS tests the battery cell voltage, temperature, relay function, and internal insulation of the battery pack. If the above conditions are normal, the BMS control negative relay is switched on. Step 2. Close the negative relay when the BMS detects that the power battery status is normal and determines that the high-voltage system needs power supply. According to the driver's operation signal, the control negative relay is switched on. Step 3. Close the positive pre-charge relay switch on the motor controller load capacitor and charge it. The pre-charged relay is connected in series with the pre-charged resistor and plays the role of buffering voltage shock when switched on. Step 4. Switch on the main positive relay after the external capacitor is charged. When the motor control capacitance rises to the preset value, the main positive relay is closed and switched on. Step 5. Disconnect the pre-charged relay after the main positive relay is connected for 10 ms. The pre-charge relay is disconnected. The ready light on the display screen is lit, and the high-voltage power on is completed. High-voltage power supply abnormal fault analysis. The key reason of pre-charge failure analysis from the sign of pre-charge success positive contactor suction from the automobile diagnostic instrument. It can be seen that the data stream of the motor controller shows that the numerical anomaly of the pre-charging voltage is detected, so the pre-charging fails. From this key point analysis, possible causes such as contactor control line abnormal, contactor body abnormal, high voltage circuit abnormal, motor controller monitoring abnormal, motor controller body abnormal. In this course, we mainly understand the basic knowledge of high-pressure system, learn the principle of high-pressure system, so as to further analyze the common failures of high-pressure system. I hope you can review and consolidate after class. Thank you.